really good at it. When you load it up with 400,000 documents, MySQL takes a little bit longer to execute that query. And it was really horribly inefficient. Luckily, Simon Willison has this kind of charisma about him. So he just popped a feature Reddit request into Redis, popped a tweet off to Antires, and just said, I want to be able to randomly fetch an item from a set. And that was what we essentially used. But that created srand member. And what it means is that the code that Simon wrote, which is written in Django, picked up a Redis set of all the available pages for each assignment. So we separated the work. If I hang on, just go back a second. Is it off screen? It's kind of off screen. So this is the primary assignment, which is information, interesting finds. We also had Labour MPs, Conservative MPs, Lib Dem MPs. We had members of the cabinet, members of the shadow cabinet, to various assignments. And we split up all of the data sets by that. So we would set up all of the pages per assignment, and then we have a set of all the pages that have been reviewed per assignment. We SDiff store the two sets, so we ask for a difference between the two sets, everything that's not been reviewed that is in the available set, and then we store it in a new key, and then we use srand member on that stored set. And the code that does that is kind of funky, as is normally the case whenever I go and look at Simon Willison's code. We just essentially build the key, we check that the thing exists, that there's a set in there, and then we SDiff store. And then the get random page works out what the key is going to be, attempts to go and get a random member from it. If it can't find a random member, it just selects a random member from the reviewed set. So to ensure that if there aren't any unreviewed ones, you get a random reviewed one already. And then finally, if it can't find that, it just tries everything it can for blowing up, which is essentially the best way of doing it. And in essence, in that whole system, that's the main thing we used Redis for. Simon used Redis for a couple of other features. So there's a Django management tool that he wrote that goes and pre-populates some of this information, builds up a few other sets that we use mostly in denormalization basis. So anything where we were asking MySQL question, if Simon didn't know how to write the SQL, which was quite common because he hates writing SQL, he would denormalize that data into Redis in order to just make it fast and make it run. The nice thing about that is it meant that the Redis was running as a single local Redis running on the Django application server. We didn't have to worry about clustering. We didn't worry about failover, because if it died on its arse, it was probably not going to be Redis, the problem. And we also had the ability to just load it up on a new EC2 instance if we needed to. So on the day that we launched the MP's expenses, Paul Nasrat, one of our system administrators at the time, managed to do what I think is probably the scariest Unix command line I've ever seen, which is that the database instance was just burning through CPU. So we went from a medium to an extra large, and in order to migrate the MySQL database from medium to extra large, we did MySQL dump, piped into SSH, piped into SQL restore. But because we'd also made a mistake in setting the wrong Unicode character set at the same time, we piped that through sed first, which I think is probably the most horrific thing you can do on a production database. But that's the way that Simon and Paul really kind of applied. So, having had the joy of looking through this code, talking to Simon about it and saying that the Redis was really quite interesting, when we came to do two new projects, we did a project called Discussion, which does the commenting system on The Guardian, and a project that was until very recently secret, which is the Soulmates project, which is Guardian dating, and that's the one I'm really going to cover. But both of the two projects use Redis in a very similar way, so I'm just going to cover the one. Guardian Soulmates is our dating site. It's one of the most commercially successful things The Guardian does. It essentially pays for, it makes more money than I think the adverts on The Guardian. It's quite shocking. Dating is really, really good. People on here love the Soulmates. There's a whole book out of stories of people who've met their friends on Soulmates. When we redesigned Soulmates, somebody wrote to us to say, I absolutely hate your new design, but I did get a date and I met the person and we spent the entire evening talking about how we both hate the new design. So even when you redesign something in a way that sometimes the users dislike the design of it, at least it gives them something to talk about. So the first thing that we did is Simon Willison and Daniel Vidro wrote something to allow us to collect statistics. So one of the problems that, that Django has is that we're essentially a Java shop, and the way we think is in a very specific way. And we want to keep count of things like the number of requests per second or the number of SQL operations per second that's happening in Django. That's actually quite difficult to do. And you can go and see this on GitHub, the code. You can bring it into your Django application, and all it essentially does is create time buckets that it just keeps incrementing as it does requests. So whenever a request completes, it says this request took this amount of time, and it has it was done once, etc. And then those numbers get incremented, and we can look at how many requests per second is a given server doing. The nice thing about that is that it doesn't matter how many threads that server's running, how many processes you split it out into in your whiskey configuration, etc. Because it's all being stored into a Redis, you just get that number accumulated across them all, which Java does for you, but Python doesn't. And we also added management switches. So we use management switches in quite a number of places as a Java shop. And I should have written a bit more about what they are, but have you all seen feature flags and management switches in your existing systems? No? So we have feature flags and management switches, which are basically the same thing. Management switches are an on-off, a global state. So we can do things like we can log onto our system, hit a HTTP URL that turns off certain features. So in the most critical example, for the Guardian CMS, we can turn off the database. We can say the database is just not available, it's not responding properly. We hit switch, and in our code, whenever it would try to talk to the database, it just throws an exception instead. And our code should be able to handle that. That allows us very easily to prevent any case where the site will be slowed down by trying to talk to something that's not available. We also have, so in our Java system, we have somewhere in the region of 70 or 80 different switches on our application server. And we can turn off various things, so related information. If you look at an article, the articles that are related to it, we can turn that off very easily. Now, we've done this for 5 years now. We've been building management switches, so more or less any time we build a new feature, if we're even slightly nervous about how it will perform, we add a management switch that lets you turn it off, so that we can turn it off on a per server basis if we need to. In Python, it's not that simple, and I'm going to just digress ever so slightly. The reason it's not very simple is that in Java, your web application container looks like this. So we deploy to Tomcat or Jetty or whatever web application container you use. You have a whole bunch of request threads serving your web application, and you have shared memory. So if you create a static variable, that's accessible by every thread across the entire system on that application server. Which means if we have a management switch, if you hit a URL on a Java application server that sets state in memory, every other request that's being processed by that application server can read that state. And so we know this has been turned off for the server, or this has been turned on for the server. However, Whiskey, as much as I love it, doesn't work that way. In most applications that you set up in production, what you actually do is spawn off anywhere between 4 and 20 separate Python processes. And each of those Python processes is running Django internally. Each of those Python processes has its own allocation of memory, and they can't talk to each other. So that proves a problem. If I hit a management URL, the only thing I've switched that switch for is that one process. I haven't switched it for the other 19 processes that are run, which is a bit of an issue, because if you have to keep hitting that switch off over and over, and you don't know which one of the processes you're going to go to, it could take you a very long time to be certain that your system is no longer serving the wrong stuff, or you've turned off a feature that's incredibly expensive or just plain